The least common multiple of two numbers is the smallest number that both of them divide into evenly. For 4 and 6, it is 12, since 12 is the first number that appears in both times tables. There is a lovely shortcut. The least common multiple is just the product of the two numbers divided by their greatest common divisor. Here is the relationship that makes this easy. For any two numbers, their product equals their greatest common divisor multiplied by their least common multiple. Rearranging the least common multiple is a times b divided by the greatest common divisor. So we first compute the GCD using Euclid's algorithm, then multiply the two numbers and divide by that GCD. One helper, one formula, and we are done. We reuse Euclid's algorithm to find the greatest common divisor. Then the least common multiple is simply the product of the two numbers, divided by that greatest common divisor, using integer division so the answer stays a whole number. Let's build both pieces live, the GCD helper and the LCM formula. First, Euclid's algorithm to find the greatest common divisor of the two numbers. Then the least common multiple is the product divided by that greatest common divisor. Now let's test it and hit run. Four and 6 meet first at 12. 3 and 5, sharing nothing, meet only at their product, 15. And 12 and 18 meet at 36. The flow is direct. Find the greatest common divisor with Euclid's method, then divide the product of the two numbers by it. That result is the least common multiple. Almost all the work is the greatest common divisor, which takes logarithmic time thanks to Euclid. The final multiply and divide are single steps, and we use only a few variables, so the space is constant. A few cautions. For very large inputs, dividing by the greatest common divisor first keeps the intermediate numbers smaller. Use integer division so the result is a whole number. And remember, the least common multiple involving 0 is 0.